Here's an introduction to the Robokit interface itself. As you can see, I've made a slight modification on mine. I've got a wire coming out of here that provides a VCC and ground line for my encoder interface, which you can see details about if you've been following the developments on my website. The Robokit interface itself plugs into the cartridge port of the ST here, and then we have 2 rows of screw terminals either side of the interface board itself. This side here are the outputs, so labelled 0 from this side to 7, and then we've got 2 ground lines, and then we've got 2 positive input lines. So that is for the power for any devices that are on the output line. So just note that the devices aren't powered by the ST itself. The input lines are powered by the ST. The output lines are powered by an external source. The sort of documented way of powering these devices is by connecting the Lego power brick, which contains 3 C-cell batteries. However, using batteries like long term, they don't really provide all the power that you'd really want. So I've attached a little pigtail connector with a DC connector on the end, and I use a power supply to power all the outputs with. So that's the Robokit itself. We'll talk briefly about what you can connect to them and how. So from the output, first of all, obviously the most simple thing you can connect is a lamp. So here's a light brick from a Lego set, and then we can connect that using a standard sort of Lego cable, which look a little bit like this. It's a grey cable with a 2-prong connector on either end, which plugs into the back of the component. The Robokit doesn't have a means of plugging in the other connector. These are screw terminals. So what you need to do is remove the connector from the other end of the lead to give you 2 bare wires. And what I've been doing is, as and when I need to take a connector off of one end of a Lego cable, I've then taken 2 strands off of a ribbon cable and created another cable with it. So I always end up with twice the number of cables I started with. So connecting a lamp to the Robokit is pretty simple. You just take the 2 ends and wire one end to ground, which will be the 0-volt line on the output line, and then the other end would go into whatever channel you want it to be connected to. So I might want to connect this lamp to line 1, so that when I drive the robot through the software, if I set line 1, the lamp comes on. Okay, so moving on to another output, let's look at a motor. Now, a motor is slightly different insofar as that it can be run in reverse polarity, depending on which way you want the motor to turn. So by running polarity in one direction, the motor turns one way, and if you reverse the polarity, the motor will spin in the other way. This is handled on the Robokit by using 2 output lines for the motor rather than wiring it to ground. So if I wanted to set this motor to, let's wire this into channel 0 and channel 1, like so, and I'd screw those in. Then when I set line 0 on the Robokit, what will actually happen is channel 0 will be set low, so that will become negative, and 1 will become positive, so the motor would spin in one direction. Then if I set channel 1, then the reverse would happen, and channel 1 would become negative and channel 2 would become positive, so the motor would spin the other way. Because of this design, it means that you can only have a maximum of 4 motors connected to the Robokit if you're using the Robokit software. If you're using my software, then you could, in theory, connect all 8, but you could only run them in one direction. Now let's look at inputs. The most sort of basic input would be a switch. The switch that's described in the Robokit manual is this, which is a homemade switch made with a paperclip, 3 pins, one of which we've covered in tin foil, and then the wires are connected to the paperclip and the tin foil terminal. So essentially what happens if I move this into its proper position, the paperclip is in contact with the tinfoil terminal, and then the switch is activated by a movement. So we can get that movement by creating something like this, which is a gear with four pins connected, slotted into the 4 holes. We run it on an axle and then put a bush on the other end to stop it from moving. And then when we attach the 2 bricks together, it means that now as I turn the axle, you can see that switch activating and deactivating as that axle turns. So those pulses can then be read by the software, and it can count those pulses and act accordingly on them. Moving to something a little more sophisticated is the Lego options. First of all, here's a Lego switch, which is essentially a micro switch in a Lego block, and the terminals are there, and that works exactly as you'd expect a switch to work. There's a little slots here that you can push an axle into, so you can activate the switch by pressure on the axle. And then the last one is the optical sensor. A lot of the stuff I do, I use opto sensors because they provide accuracy. So an opto sensor looks a little bit like this. It's got a hole for the axle to pass through, and then this here is the actual light sensor. So it can detect, for example, the presence of a yellow brick, which will reflect the light back into the sensor. It can detect a black Lego block in front of it, which won't bounce the light back, and that will actually register as a 1 in the software, or in the software that comes with it. And then moving on from that, you might want to use what's called an encoder wheel, which has black and white stripes on them. One side you get 8 black marks, and then on the other side you get 4, so half the resolution. You pass the axle through the opto sensor, and then as the axle turns, the black marks register as a signal on the input line. And for any input you want to wire in, it's always the same. So you always connect one end of the input, one end of the switch into one of the input lines, and the other end will go into the 0 volt line. So you can have up to 8 inputs. It's worth noting that out of the box, the Robokit would only support an opto sensor on the first 2 channels, so that's 0 and 1 on the interface itself. That's because there's extra circuitry that's required to be able to differentiate between a 1 and a 0 on the opto line, and the board only has that circuitry on the first 2 channels. Those who have been following what I've been doing will know that I've replicated that circuit, and here's a prototype board of that circuit. So by adding this to my board, I can then run 2 additional inputs and convert them to be able to interpret opto sensors. So that gives me the capacity to have up to 4 opto sensors when I've got this board attached. So there you go, there's a quick introduction into the Robokit interface, and the next thing we want to do is move on to talk about the software.